Also, I just really like free time. I wait all day to get the lunch to do nothing.
So, for the rest of us, we have... By the way, I've had a bunch of classes ask me, so this is the date that I will finalize my grades for the first 9 weeks. That's when we'll be set and done. Besides that, remember Friday is an early release. I will actually have you right before lunch. So we will continue on with the lesson. And you have a lab on Monday. I will look at you and tell you. It's going to be very interesting. How many of you would like an opportunity for some bonus points?
Me.
I'm going to give you an opportunity for some bonus points.
I'd love to know.
You all, in first period chemistry, will be having a lab on Monday. The key to it is there's an opportunity for some bonus points in the class if you can solve a problem I'm asking you to solve. But I also offer bonus, because this is one of those, if you hear the question or you get the question from first period, then you can do it rather fast. So if you can get someone from first period to tell you what we did, I will give you 10 bonus points. Now, on the flip side, for them, I'm offering to them, if no one in 8th period can tell me, then I will give them bonus points.
That's kind of unfair.
No,
That's not.
That's what you think. I have had people
Andrew,
tell
we
me.
literally have a friend in first period. I have hundreds of dollars. I will pay.
Yeah.
Do we want to pile money together and give it to one person?
You can tell me the day of, because
What's the day of?
You help me.
it's going to be Monday.
Monday?
I will ask you a question.
When are you
And
telling
you-
your first period?
I'm telling them tomorrow. They have no idea what's going on. They will be aware and know before you all get the opportunity to ask them. They have no idea what's going on. This is one of those that you have an opportunity, but so do they. So, best of luck. It's always a fun little game. I like to play it and see how many people from first period are getting slammed. One year, a guy got tricked, and I felt so sorry for him, but I was like, dude, you cost it for the class. Like, I can't give him bonus points. Women.
Can we threaten them with violence?
No, that'll get you in office and
Can
in
we
trouble.
pay someone else to
Can
threaten
we
with
seduce
violence?
them?
I have a lot of problems with that, so I say no.
And
Okay,
they're
Owen's
both
off the
age of
table.
consent for each other.
Alright, listen, Owen's off the table. We need to figure somebody else out.
Okay, so we have started with this idea. I asked you this question. What is light?
What is that? Maybe,
It's a white.
Well, it says in first
Hey.
Genesis.
I know what it is.
What is it then?
Well, he's not asking me. He's just looking around honestly.
See that thing above you?
Yeah, it's gonna like, kind of shoots me in the foot for a second. Okay, anyway, we said light was a wave. And hold on a second before I get carried away here.
Life is lovely. I run out earlier.
Here.
What a friend. Hold on, I gotta make sure I haven't changed something.
I should put more than like 10 pieces of paper in my
Okay, anyway, so we proved that light was a wave. What experiment proved light is a
Double
wave?
slit.
Double first
Double
Genesis.
slit. Don't say anything about the double slit experiment.
Why?
Pretty cool.
Because Eric's taking the quiz right now.
Can you whisper it to me?
It's in the video.
Did you whisper at any point in the video?
Okay, so we can't go into detail, but I will hit back up here in a second, as soon as Ariel's done with her quiz, of how the double slit experiment proved light as wave. Now, today, I want to go into something else. Still sticking with it. We're going to look at something today. There was another thing that I asked you. What is light? Is it a wave or is it a particle? So, this idea got destroyed. So, way a long time ago, we thought we had it all figured out. We had a wall of physics. Imagine it as a cement cinder block wall. It's like, this is physics, it's strong, it's got a couple cracks, it needs some repairing, but pretty much we're set. And then, one of my favorite scientists showed up on the scene. It's one that's very famous to you all as well.
Sigmund Freud.
Thomas Edison.
No.
Albert Einstein.
Albert Einstein. Albert Einstein changed the whole premise and idea of what we look at and see in the world because of something that he achieved and got his Nobel Prize for. So, this whole idea of light being a particle, does anybody know what Albert Einstein got his Nobel Prize for?
Being smart.
I cannot recall.
Wish we could like FaceTime John right now.
You want
This is where I was wondering.
If I had the Wi-Fi, call him. All it takes is that password.
I got the Wi-Fi.
Not happening. It's not what you think. Everybody thinks it is his relativity, general theory of relativity. Everybody thought he would get it for that. He actually did not. He got it for explaining something that if you do it, your parents will kill you for making them buy a new microwave.
Putting aluminum foil in the microwave.
I prefer to put a spoon in the microwave. This feels funnier.
Well, I'll put a spoon wrapped in aluminum foil.
Sport crap.
I'm not putting a spoon wrapped up in aluminum foil in a microwave with thermite. The photoelectric effect.
What if I just put like nitroglycerin in the microwave?
So, the photoelectric effect.
I'll have everything except that.
Andrew, this is why you're doing bad.
No, I have all the notes. I just not.
Clearly.
Alright, so photoelectric effect. Here's the idea of photoelectric effect. Let's say I have a piece of metal. Everybody say hello, metal.
Hello.
I love it how y'all actually say hello to it.
Why wouldn't I?
So here's
Yes,
the interesting thing behind what is taking place, what's happening. Is, let's say for example, Mr. Hall takes some orange light and he shines it on the metal. Nothing happens. So Mr. Hall's like, oh, what if I increase the energy? You know what has more energy than orange light?
Red.
Okay.
Green?
Red has less energy.
Blue.
Blue. Still yet nothing happens. Well, hot diggity dog. Let's step it up a notch. Mr. Hall gets a little crazy.
Oh.
Gets a tanning bed.
Oh, God.
I'm gonna put this metal through it. Oh. And I set it in the tanning bed, and I put, what's in tanning bed?
Ultraviolet.
UV, ultraviolet ray. And here's the cool thing. Now, you know how normally Mr. Hall looks at you and tells you all is fair game? Okay, what I'm getting ready to say is going to come up later in the class, but I'm going to say it now to explain to you how this phenomenon can actually take place. But what is about to come out of my mouth right now, dealing with metallic bonds, it's not fair game right now. Okay? Mr. I will not put it on a quiz.
Okay.
You all can shout hallelujah later. So, metals
Hallelujah.
have metallic bonds within them. And this is how metallic bonds work. Metallic bonds are big brain.
Oh.
Had this big brain idea. Everything's based off the octet rule. Everybody wants to be like noble gases. Well, the metals, you know, they were chilling one day and they look and they go, wait a second. We got too many of these here electrons. Why don't we just take them and move them somewhere else? So they came out and they were like, ah! Get out of here!
What did it do to you?
Kick those electrons out.
This is racism. Against electrons.
It's an electron. It doesn't have a race.
I don't care. It's a particle. It's a different particle.
This is what happens that UV light comes in. It's got more energy, right? Because as we move from right to left on the electromagnetic spectrum, it increases in
Nanometers.
Wait, what?
Radiation. Yeah, radiation.
Energy.
energy. Thank you. That's what I was just waiting for energy. Thank you. So then what happens that UV comes in? Oh, I was about to do purple. Hold on. And then this weird thing happens. Electrons just start getting shot off.
Fly around, man.
We got a problem. We have an issue.
Uh-oh.
What are electrons?
Negatively charged things in a atom.
Particles.
Subatomic.
Subatomic particle.
Negatively charged subatomic particles. So we got a problem. What is electromagnetic radiation? So we have a wave knocking a particle off of something. Now hold up, that's a major
Carla
issue.
Sizemore to the office. Carla Sizemore.
Because it makes sense if it was like, you know, a particle on a particle. That makes perfect sense. Like, you know, we go bowling. I take a bowling ball. As long as it doesn't go in the gutter, it hits one of the bowling pins, they fall over. Makes sense, right? But then a wave knocking a particle out. What a dilemma. So, Albert Einstein, big brain, literal, no joke. He comes and looks. Got this?
Stop looking at it.
Okay, anyway, so.
Albert Einstein.
Albert Einstein came to look at it, and big brain, literal. Yeah. Okay, back to this. He looks and figures this whole thing out. He's like, wait a second. Clearly, there's only one explanation here.
Eviction.
No. Light is a particle. Then opens up this whole world of, wait a minute. Now hold up. It's wave. We have proof that it's wave. So now Albert Einstein's like, we have proof it's a particle. Let me introduce you to wave-particle duality.
This is good.
When something can be both things. So, the photoelectric effect explains how electromagnetic radiation will yeet out
He's hit with the gears now.
I don't think it's getting any better than this.
Not with that attitude.
Well, I think I at least got 2, but it's better than a 0. So, practice sheets than it was on that test. Just to say it, please.
Okay, sorry. Explains how electromagnetic radiation will yeet out electrons.
Do you mean you just throwing something?
Yeet it out, yeah.
I'm pretty sure it's supposed to be 2 E's.
2 E's.
Yeah.
I
Yeah.
did that. Oh no, I did not. I did 2 T's.
Yep.
There we go.
Yeah.
If you're watching this and you're in first period, and now like everything's rolling and I understand what you meant. Okay, well yeet out electrons. I'm trying to get with it with y'all.
Good try.
Proving electromagnetic radiation to be a particle called a photon. Give me a moment and we shall define photon.
Is the spelling and bee fair game? Can we have that on the test?
Lord, no, I don't judge you on your spelling anyway. You ever watched my spelling?
This is a scientific term for throwing out electrons, in my opinion. I think we need to know
We
this.
should push for that.
Scientific.
Merriam-Webster. We can prove we can do it.
Do what?
We should we should push for that. We can get that Merriam-Webster. You can do that.
Yeah, that's
They define words as like the usage. So
Okay. So this photoelectric effect was Albert Einstein. He actually got his Nobel Prize for this. And he wrote this paper in 1905. And it explained how electromagnetic radiation, which light is electromagnetic radiation, is a particle. So how is it proved that light is a particle?
because
it's knocking out.
The photoelectric effect. What proved that electromagnetic radiation is a particle? Photoelectric effect. What proved electromagnetic radiation is a wave?
Double slit experiment.
Double slit experiment. How did the double slit experiment prove that it was what?
Interference pattern.
Interference pattern.
Golly gee, I could have got that one right if I had just been
In
eating.
class. So interference.
I didn't put that.
Good job. I was gonna correct you.
Thanks, man. Appreciate it, Greg.
I'll give you a second to correct it.
Normally I would have just left it and not cared. So, particle, the photoelectric effect proves electromagnetic radiation of light as a particle because of the interaction between it and an electron, which brings in an idea and a new understanding of what that particle is. We call it the photon. Photon is a particle. Drake and John, if you're watching this, this is a Mr. Hall definition, not a Google search definition. It's a particle of electromagnetic radiation that has a certain amount of energy, but no mass.
That's big.
You think no mass?
No. I think no mass.
Stay. Good boy. Okay. So we're introducing you this idea of a photon. So, you guys remember that fun test lab we did?
Yes. Fire.
Yes. Okay. This is where this whole idea is coming from. Behind what's happening is interactions with energy and electromagnetic radiation. So today I want to bring us into one of my favorite ideas. Have you ever heard of ground state?
Of what?
Ground state.
Have something to do with like electricity or something?
No, but that's a really good guess.
That's what I was imagining, but I
Isn't
don't
that the
know.
thing, like, when you're conducting electricity, you have to have a ground and then...
Really good guess, but no.
Oh, state.
Yeah.
That's the lower half of the United States, okay, I get it now.
Electric state.
So is that not just the state of being ground? No electricity. Well, no, I just know you were saying stay or stay. So is that not to do with
Ground state. The state at which you find electrons in their normal energy level. Now, I'm going to draw something here before anybody blasts me. I know we no longer accept Bohr's model, but we use Bohr's model for this.
you?
What I've drawn here is a Bohr's model of an atom. We're going to keep it very simplistic. I use this to demonstrate, show this idea. So, there is a pop culture reference that I love to use whenever talking about this. Does everybody in this room remember SpongeBob?
Yeah.
Okay, SpongeBob is ready. I hope you are. What this is a Bohr's model, and every one of these circles is an energy level. So, N is the quantum number, principal quantum number. You'll learn more about it later. But it tells me this is the first energy level, second energy level, and third energy level. So you got SpongeBob. SpongeBob's just kind of chilling and hanging out. There he is. Until one day, it goes crazy in Bikini Bottom.
Oh.
And then SpongeBob has to come to the rescue.
What's those little numbers or letters?
N,
Uh-huh.
that's all it is. It's just N. It's a little N. So, SpongeBob has to save the day. If you don't remember this story, SpongeBob has to go to Shell City, find the crown, and save Mr. Krabs, right?
Cover the vault head.
Yes. Do you all remember of a certain establishment that SpongeBob and Patrick visited on their journey to Shell City?
Yes.
Big big guy?
The Salty Spittoon?
Oh.
Do we all remember the Salty Spittoon?
We're going on a baby hunt and don't think we don't know how to weed them out.
Okay, so the Salty Spittoon. So in the Salty Spittoon, you remember if I'm going to get in the Salty Spittoon, I got to be tough, right?
Right.
Sure.
Right?
Yeah.
Right.
Thank you.
Indubitably.
Little class involvement, it makes me feel good about myself. Thank you. Okay? I won't go home and cry tonight now.
I will.
I'm a Lions fan.
All you do is cry on
Nothing not to
Sundays.
cry about in my life.
So if I get in the Salty Spittoon, I got to have muscles on my muscles. I got to have muscles on my eyeballs. I got to have so much toughness that I can eat a bowl of nails.
Without any.
That's not from the movie though.
Is that not?
It's not
No.
from that part of the movie.
It's
a
not
different
in that-
episode.
Yeah.
That's from No Winnie's Allowed. Come on, Mr. Hall.
3 different
The episode No
That's
Winnie's
from
Allowed.
Junior.
Yes.
Yeah.
He slips in
Yeah.
an ice cube and gets covered in boo-boos. And then they sit on the Weenie Hut.
Alright, I apologize, dear God. You get the point, okay? So this is like the salty spittoon. And then this is like a bigger salty spittoon. And that's even a bigger salty spittoon. So the thing with these energy levels is you have to have a certain amount of energy in order to get into that energy level. So I'm going to write some figures up here now. Do not come at me. These are not the actual numbers for this, but this is just here to get you to grasp and understand what is going on. So let's say for the first one I got to have 10 joules of energy. The second level, let's say I got to have 17 joules of energy.
That's almost double.
So question to you, if the electron has 16 joules of energy, can it go into the second energy level?
No.
No. He's still eating his nails with milk. Now the third energy level, let's say it's like 20.5 joules. Darken that in. So 20.5 joules. Let's say the electron has 20.4 joules of energy. Can he get into the third energy level?
No.
No!
If his best friend beats himself up, then he might be let in secretively.
These are all levels. Now, if you all remember, we did a lab.
Fire. Fire.
In this lab, we burned sticks. So we took sticks and we shoved them into a flame and they turned colors, yes?
Yes.
What is happening? What is going on at this point? What is taking place?
Fire.
You wonder? Me too. Me explain to you what is happening. Fire is really hot. A good version of energy is heat. This is a great source of energy. So let's say we have energy. Comes in. That electron absorbs the energy. If it's enough energy, then the electron is allowed to go to another state. Once it does that, and it jumps to the higher state, it now moves on to something different. Once it goes to the higher state, it's something we call the excited state.
Cool. Die hard.
This is the state at which you find electrons in higher energy levels than normal. So, we get some energy, we jump over here to the second one. Oh, I gotta label my energy levels. So sorry. Here we go. Energy levels are now there. So now we're in the second energy level. This electron is used to being in the first energy level. So in this case, how much energy does that electron have now?
17, 10, 20.5.
17 units matter. What's the unit?
Joules.
Joules. Thank you. 17 joules of energy. How do you know that? It's in the second level. It's in the salty spittoon. It's tough as nails, right?
Yep.
Only way you're getting in. Now the cool thing is, this electron is not used to being there. So this electron has all sorts of problems. It's like, yo, it's cool. It's kind of like SpongeBob and Patrick. We're not used to here. We don't want to stay here. We got to get out. Peace out, home dogs. So they getting out. When they do this, they want to go back down to where it normally is. But here's the problem. It's got 17 joules of energy. Can it get in the first energy level and hold on to that?
No.
How much energy does it have to have?
10 joules.
10 joules. It can't have that. So then when that takes place, guess what happens with it?
Explosion.
Energy has to go somewhere.
Heat.
Law of conservation of energy. Energy can be transferred into something.
Heat.
What is something that is a very good indication
Heat.
and a very good source of energy,
Heat.
but no mass?
Heat.
Photon.
Heat.
So it releases out photons of light.
Man.
Photon. Yay. So the photon comes out. This is how the energy is getting released. You ever want to know how you can see things? You see colors. You see bright, vibrant things. When we turn on a light switch, why do you see stuff? This is why. This is what is happening. We turn on the electromagnetic radiation, hence the light switch. And we see the colors. We see everything. Because electrons are going to higher energy states and lower energy states. I know. We're all confused right now. Let Mr. Hall help you.
I turned it on. I'm scared of the dark.
I kind of just feel bad for the
I is here to help.
He's getting bullied for no
Don't y'all let me forget to hand these papers out.
working in the death for.
I want to introduce you to my little friend.
Oh.
Yeah.
Oh no.
The first energy level.
He doesn't look very
Wait.
good.
Second energy level. I should drink your coffees in the morning. First period, I apologize. I'll fix this tomorrow. The ground is the first energy level. Then we have the second energy level. So, the second energy level, I can get up here. See?
See.
Okay, for all you that think I'm too fat to do it, I just proved you wrong. I just did it. All right, say C.
See.
C. Thank you. Please come again. All right. Question. If I only have enough energy to get my foot to right here, can I get on the desk?
Yes. You can lay down.
Yeah! Woo, man. If I took that trip, I'm on the hospital.
You can use other methods.
Andrew, you're in timeout.
What if it's
Thank
like
you.
that invisible box trick where you have the leg up and then you like.
This is not the trick. I am risking my life for your knowledge. This is the love Mr. Hall has for you. If I go down, let's get this all straight, okay? First thing, somebody over in this area, because y'all are ladies, you're very caring and loving, call my wife.
Can I get Roscoe?
What?
Can I get Roscoe?
No, my wife's still alive. And what's my dog? Okay, then second, let's,
Post the video for everybody to see.
okay, thanks. Don't let the video go bad.
Hashtag Connor Gibson. Gibby.
You run to the office and tell the office that Mr. Hall is falling and he can't get up.
Randy Black alert.
I do.
So we just buzzed him?
No, just send him. Let Andrew run.
I got you.
I don't know if you'll make it by the time we get there.
Then from there, you know,
Tiny thing.
somebody like,
Bitty.
well, yeah, hopefully I ain't dead.
I can't wait to steal all of your
If I
pencils
do-
while you're unconscious.
What? What'd you
I
say?
can't wait to steal all your pencils while you're unconscious.
Okay, good thing. Abby, you lock my desk up so he didn't steal my pencils. Okay, so if I have enough energy to get my foot here, can I get up here?
Yes.
Yeah.
Yeah, I can.
What if your knee's not strong enough?
Are you calling me fat?
No, I'm saying it's very likely that you will fall because I know people are clumsy.
Now you call me clumsy.
I call everyone
You
clumsy.
call me fat, you call me clumsy
I
anymore?
don't think you're fat.
Look at this.
You sound like a Twitter user.
Okay, next. I have a job for you.
Okay.
You
I'm
feel like
waiting
this
for him to
job?
take this.
I will yell at you.
Do Do
Don't
not
drop that.
those. You can set them
You
on
can
your
set
bed.
it.
Mr. Hall, I swear if you go to the ceiling next.
I just pull out a towel. There's a ladder. And I go up here.
Now this is the 5th energy level. And my
Okay.
escape.
I'm going to go with Walter White.
This is where everything gets a little wobbly, okay? Fat guy and heights don't mix. Okay, if I have enough energy. Oh wait, y'all can't see that. If I can get my foot to here, can I go up?
No, you're
No.
going on
Yes.
No.
No.
Andrew, you're in timeout.
Ah.
No talking.
Hidden box.
Okay, if I can get my foot to here,
Yes.
yes, I can go up. Now, here's the thing. Anybody that knows anything about energy, right now, Mr. Hall, fat guy, I have increased my elevation, so I have increased my potential energy.
Got a lot of
Crowd surf.
Yeah. No. Okay. I have a lot of energy stored up right now, right? Got a lot of energy right here. I'm that electron. I'm in this excited state. I have a whole bunch of energy.
Please don't jump off.
Don't jump out of the cell. Don't jump out of the atom.
The cell?
So, this is the 5th energy. I'm just kidding. Hey, wait a second. I ain't never looked up at it.
Fucking die.
Holy smokes.
He's gonna get electrocuted. Like, I got 8th energy level.
Those are some professionals that ran that wire.
How's your
There's a wire. There's a wire. Oh god, there's a wire.
Oh, don't worry about it. It's just electrical. Oh. I take it back. Whoever ran that wire was not a professional. Okay. Law of conservation of the energy, not mass. Okay.
Heaven is the last energy level for you.
Okay.
Oh, be careful.
What would happen and what will we feel?
Death.
You don't say nothing. You're in timeout. You don't say anything either. You're gonna call me fat and clumsy. If I jump from here and hit the ground, what are you gonna feel?
And knee replacement.
Agony. Suffered.
You're gonna need a computer chat photo.
You are in timeout. I have no words for you today.
Can you put the whole
Done.
class in timeout?
It's about time to go.
I've done nothing.
Quiet mouth.
What are we gonna feel? And don't say nothing about China feeling anything. You're gonna feel vibrations. Even though you're in timeout, you give me what I wanted. Now shut up. Hey, you're gonna feel vibrations. Wow, all that energy, it's stored up. It has to go somewhere, because whenever I come down,
Oh!
That was rude.
whenever I come down, you feel the energy has to go somewhere.
Yes.
So it transfers from the ground. It's the same thing here. Energy has to go somewhere. Where's it going to go?
Out.
It comes out in the form of photons. And this is where I will pick up with you tomorrow.
All right, Abby.
Thank you.